Good morning, ladies and gentlemen. Welcome to the group exhibit Hydrogen Fuel Cells Europe here at Hanover Fairground 2023. I'm also welcoming all our online guests. We are live streaming from the fair. I have a little quiz for you. Guess in which year we started here talking about hydrogen fuel cells, and at that time we did talk about batteries as well. Which year did we start here at Hanover Fairground? 1995. So in 1995, we started here with 7 or 8 exhibitors talking about the future. And at that time, no one had an idea what hydrogen was. Hydrogen sounds chemical, but no idea. This year, 2023, we are exhibiting here with 270 exhibitors from more than 20 countries. So that is a huge step, and we can already feel that hydrogen is not an innovation anymore. We are here at the fair to talk about business. It's quite interesting. And the technology is developing further and further. So we developed a format, a technical forum here, where you get more insights about the technology, the latest technology, and also see the engineers working behind that. Every 15 minutes, you will have a new topic here in the technical forum. My name is Mona, and I'll be your moderator for today. Our next topic will be the efficient tensioning systems for fuel cells. We will have the Manager Innovation Hub from Kamax Automotive. For that, please welcome with me on stage Mr. Dennis Dutenhöfner. Welcome.
Yeah, thank you. Yeah, hello everyone, and thank you for the opportunity to have this speech at Hydrogen and Fuel Cell here at the Hannover Messe 2023. We are from the company Kamax, and I'm going to tell you today what our products have to do with hydrogen, even because who knows, Kamax knows that we are a manufacturer of bolts from history. And I'm going to show you what we did with bolts to get into the hydrogen business and what products do we offer today. My topics today will be a short introduction of Kamax, who Kamax is, what our product K-Expanded, so-called K-Expanded, is about. Then the tensioning system for fuel cells, so the system that clamps down a fuel cell is developed, and the behavior of this tensioning system during operation and while assembly of the fuel cell, and what we do for the future to make these kind of systems very efficient, one in manufacturing and two in the product function. First, let's talk a little bit about what is Kamax even. We are the mother company. Kamax here in the middle at the top is the company that is founded 1935 in Osterode am Harz. We are making bolts from history, ultra high strength bolts, the strongest bolts in the world that are mass produced, by the way. We have different departments in that company. For example, InnoHub, where I am located, so a company that is a department that is for the diversification of Kamax. We have Nexenir, a digital company. We have Robert Schröder, precision machining company, coating, full service provider, and a joint venture as parts of our company. All centered around mechanical parts in general. And we have 4,000 employees on 19 locations worldwide, on every continent basically, and produce 2.7 billion parts, most of which are bolts. Our product portfolio so far and in the past from history is including bolts, fasteners, assemblies. You can see here a park brake, for example, that is coming from Kamax, which is manufactured by different methods, precision machining and cold forming. You can see a warm forged, more complex part, and you can see like this is from an e-bike actually, the shaft from an e-bike. One of the product groups we developed apart from that is our K-Expanded bolt. And as you can see, this is a particular long bolt. And what is so interesting about a long bolt? When you think about the manufacturing process of a long bolt, it tends to be bent. It tends to be not straight. And to manufacture a very, very straight long bolt is very difficult. So what we try to do is we separated the head from the shaft and manufacture them separately from each other and put them together afterwards. This allows the shaft, you see here in the lower picture in orange, allows the shaft to be particularly straight. And if you look at the product and if you go around this, all of the booths here, you will realize where this product is might be located. We are able to have different kinds of heads on top, also heads with different kinds of function we can put on this board. For example, like attaching something to the head without having an additional clip or something is possible. The assembled parts are tested in line, so each part that is produced is right away tested, and we have different functional coatings against corrosion, for example, but also against electrical conductivity or with particularly high electrical conductivity if you want so. For example, these bolts can be used for fuel cells that have this kind of architecture like shown on the left. You can see there the end plates at top and bottom. In between the bipolar plates, a stack of bipolar plates and membranes. And our product is all around this fuel cell to clamp it down, basically. Our bolts can clamp up to 600 millimeters, but we are also very variable in length. We can do different head sizes, different head geometries to optimize the force on the end plate, on the top. We can do small batches as well as large batches, so we are able to scale up because we have cold forming as our core technology, which is a very scalable technology and a very fast process as well. And as I told you, the high standards concerning the straightness of the bolt allow for an easy assembly of this kind of system. Because if you think about how you assemble it, you have to put it from the top, and from the bottom you have to straightly fit to that hole on the bottom. So that's very efficient to do, and compared to conventional rods, you don't have to put a nut on two sides, but you can only put a nut on one side. Therefore, the assembly process is way more lean. From there, we started to get involved a little bit with how fuel cells even work. And we took a look at the force and elongation diagram from the fuel cell itself. And what we tried to figure out is, as you clamp down the fuel cell, how is the force generated? And this is like, you can see it in this diagram. This is a real measurement, by the way, from our system. And we can also measure by the bolt itself, like during operation, for example. What we saw by that is that a regular bolt can easily supply these kind of forces. This is a really easy thing we can do with a bolt. It gets a little bit complicated, however, if you look at how does the forces distribute in the system when you look at the operation of a fuel cell. So during operation, we measured with our bolts, using the bolt as a sensor basically, we measured during operation what the fuel cell is doing. And what we come up with was, you can see here in orange in the right diagram, you can see the power demand of the fuel cell. And in blue, you can see the elongation of the fuel cell. So both end plates, the distance between both end plates, basically. And what you can see here is that the more power the fuel cell demands, the more active the chemical reaction within will be, and the more distance between the two end plates will be generated, which is in the end resulting on a very high mechanical load on the fuel cell tensioning system, which is the bolt in the end. So we came up with a system that can cope with these kind of operational loads in a fuel cell. So what I mean by that is we have developed a system. It's not about the bolt anymore, but we have developed a system, a tensioning system for a fuel cell, which can eliminate all of the material which is here displayed in red. So none of it will be present anymore. The building space, therefore, is up to 40% reduced, depending on which system you are coming from, basically. We are able to supply the assembly force while assembling the fuel cell completely, partially without a press, depending on which system you are looking. We are able to be compensating the internal pressure of the system. So by internal pressure, I mean what I showed you earlier during the operation. We can compensate that by the clamping element itself. So it has a built-in function to compensate for exactly these real loads, these operational loads. While the complete system becomes less complex. Usually in these kind of systems, there are springs of some kind, yeah, like spiral springs or disc springs involved. To compensate for that, we are totally eliminating these kind of components and integrating it into our bolt system. Therefore, you have a less complexity while assembling. You need less different kind of parts, a less variety of parts you need for assembling your fuel cell. And therefore, we have significantly reduced time for the fuel cell assembly, as you have a lower amount of bolting places where you need to bolt. Here you have many places where you have to set up the wrench and bolt it tight. In our system, this number of tightening points is reduced significantly. So what we can do at Kamax now, developing from a bolt manufacturer to developing our product to be fit for hydrogen, we can now assist you with the architecture of your fuel cell tensioning system. We have gathered plenty know-how, and I showed only a fraction of that. You can come to our booth, the Hessen booth, and there you can talk to our engineers in detail. We can consult you when it comes to the supply of components for your for your tensioning system. Almost every component which is part of your fuel cell tensioning system, we can supply it. We can instrument, so sensorize your fuel cell by our bolting components to get you the best result for your tensioning system in the end. We have plenty of know-how from material and coating research. I have been a material engineer for 5 years myself, so I know what I'm talking about at Kamax. We have functional coatings that are about blocking electricity or conducting electricity, are able to avoid corrosion, and so on, are able to adjust the coefficient of friction. And we can act as a development partner for future generations of your fuel cell tensioning systems, if you want. Thank you very much.
Thank you very much. And if you want to take this conversation further, you can visit them at the booth. But if you have a question now, I can allow maybe one question from the audience. Lots of pressure on you now. But if you have a question, just let me know. Then I'll come down to you. I know it's still early in the morning. Okay. That's all right. All right. Well, then thank you very much, Mr. Dutenhöfner. You can visit them at the Kamax Automotive booth.
Thanks.